Yeah, hi everyone. Finally, I'm live, and in this session, I'm going to talk about problem on transient, right? So there are many people, they always face problem solving transient. Okay, so how to solve problem based on transient? That is one of the very important key, right? So before you take up any problem, you need to understand some of the important concepts, right? कि जैसे problem अगर given है, the moment you see the problem, you should be clear with the steps, right? Okay, you have to do this, then this, and you get the answer, right? You don't have to waste your time, right? Okay, that you have to make sure always. So in this session I'm going to discuss some of the problems. Okay, how to approach to the problem, right? So in the beginning I will discuss the detailed procedure of analyzing circuits like RC circuit or you can say RL circuit. Okay, and then I will tell you some of the important steps. Okay, that okay, these bigger steps you can ignore and you can get the answer very quickly. So yesterday I was having conversation with one of the student, right? So I gave him also one of the technique, right? So all those technique we will discuss. So I believe everything is okay. My voice and everything is fine. And yes, please confirm once. Okay. So in this session, what I'm supposed to do here is I will be just taking up, let me decrease myself. Okay, fine. So I will be sitting here and yeah. So in this session, what I'm going to talk about is the transient. Okay, transient analysis basically. And we will try to understand what is the meaning of analysis here, right? What do we want to analyze, right? So basically we will take the circuits like RC circuits, okay, and we will talk about RL circuit. These two circuits I'm going to talk, right? And how to analyze them. Okay, how to analyze them, that is the main objective of this session. Okay, how to analyze. Yes, hi Divyani. So how do we analyze RC circuits, okay, and how to answer some of the questions based on RC circuit, right? So, okay, so basically I will be discussing the DC transient, okay, the input which I will be giving to these RC circuit, okay, to excite is the DC input, okay. You can say step input I will be giving, and then we will see the behavior of the circuit, right? Behavior of the circuit. So suppose if I take two resistances here, right? These are the two resistances, okay, and this is R1 and this is R2. Okay. So there is no capacitance or inductance connected in this circuit, right? And if we apply some voltage, like you can say V voltage, we are applying to this circuit, okay, to excite this circuit. So what is, if somebody will ask, what is the voltage across this resistance R2, right? So what is your answer? Your answer should be directly what? By voltage division, right? You can directly find out the voltage across R2, that is V R2 is gonna be total voltage times R2 by R1 plus R2, right? So in this case, there will not be any sort of transient, right? Because there is no memory elements like memory element like capacitor or inductor, okay? So this kind of a circuit is very easy to analyze. Whatever input you connect, okay, just apply the input and you can find the output voltage. But if I'm going to replace this R2 with the capacitance, okay, suppose this is the resistance, okay, this was the first circuit we have taken, R1 and R2, right? And we are able to find the voltage, output voltage here, right, by applying voltage division. Suppose I'm going to take I'm going to replace this R2 with the help of capacitance, okay. So there is a capacitance here, okay, there is a capacitance, okay. So you see here, this is the capacitance and this is the resistance. Now we are asking what is the voltage across this capacitance. You can say V out or you can say VC of T, right? The voltage across the capacitance will be what? This is my question. And if we are applying some voltage, you can say some DC voltage, V, right? So both circuits are same only, but only one difference we have brought here is in place of R2 we have connected capacitance. Okay, so entire behavior of the circuit got changed, right? The behavior of the circuit will change here, right? That you have to understand always. Yeah. So whenever capacitor and inductor, okay, will be present in the circuit, okay, whenever inductor and capacitor will be present in the circuit, and if there is a switch, okay, in the circuit, if there is a switch also, right, like you are giving some input, okay, at some time, okay, and then you are removing the input at certain time, right? So in that case there will be a transient, okay. So uh, these are the two memory elements, okay. We call it memory element. Why we call it memory element, capacitor and inductor? Because capacitor stores charges, and inductor, inductor also stores kind of energy, you can say magnetic energy, and the capacitor stores electrostatic energy, okay, that like half cv square kind of thing, okay. So that is what very important concept you have to understand. So if you have to analyze this circuit, okay, RC circuit, so let me take here RC circuit, okay. This is simple RC circuit, okay. This is simple RC circuit, and this is R, this is C, okay. And you can say that this is the input voltage V, okay, V input, right? So this is a capacitor, right? And capacitor is basically a memory element. So you have to keep in mind, guys, that whenever you will apply some input to the capacitor RC circuit, okay, this capacitor has to charge, okay. Initially you can consider that this capacitor is not charged. Initially capacitor is discharged, okay, like you can say at rest also, okay. Zero voltage is there across the capacitor. Now the question is, when you apply some voltage, you can say we are applying some kind of a voltage like this, okay, like at t equal to 0, okay, we are applying this voltage V, right? Before t equal to 0, what? Before t equal to 0, there is no voltage applied, right? And also we have considered that this capacitor is not charged, it is at rest, okay. Zero voltage across the capacitor, or you can say zero charge across the capacitor, right? Okay. The moment you apply this step input, okay, this is called step input, right? This is known as step input, that you have to keep in mind. So what will happen? You can't directly write the voltage across the capacitor, okay. Why? Because voltage, the moment you apply some voltage across this RC circuit, what will happen? Your capacitor will start charging. And how capacitor charges, that you have to understand, okay. Hi Devansya, how does capacitor charge? Capacitor charges when current will flow through the capacitor, right? So what kind of current will be flowing through this? You can say IC is flowing through the capacitor, right? IC, okay. If the current IC is flowing, okay, and whatever current will flow here, IR, you can say, okay, current is flowing through resistance, you can say, and this current, when current will flow through this capacitor, then only capacitor will start charging, okay. So initially your capacitor is not charged, okay, remember. And to charge the capacitor, a capacitor will take time also, right? Capacitor cannot charge the moment you apply the input, right? That you have to make sure, understand. So initially what you have to do here, initially this current, okay, like what is IC basically? You know that C dV Cy dt is equal to IC, okay. C dV C dt equal to IC, right? So what is the value of IC? What amount of current will flow through the capacitor and capacitor will start charging? Initially I'm talking about, okay. Okay, at the moment you apply the input, you can say at t equal to 0, right? So I'm just going to take some time instant here, like t equal to 0, you can say at this point the step is applied, you can say switch is closed, okay. The moment step is applied means switch is closed, right? So this will be the current, okay, this will be the current which will be flowing through the capacitor, right? I mean, what is that current, tell me here. So initially the capacitor is not charged. It means what you can say, what kind of comment you can make here. The capacitor is not charged. It means that the voltage across the capacitor is zero. And what is the meaning of that? The voltage across the capacitor is zero. You can say that this capacitor is replaced by short circuit. Okay, you can always do like this. See, now we are removing this capacitor. Okay, and the current is flowing IC. Okay, this is R, right, and this is at t equal to 0. We have applied some voltage, you can say 5 volt or volt only, right? So what is the voltage, what is the current flowing through this capacitor, but at you can say at t equal to 0? Yes, at t equal to 0 plus, the current which is flowing here is, you can say IR will be flowing what, 5 upon R. The voltage 5 volt, okay, upon R, which is flowing through this capacitor. You see here, this will be equal to IC as well. Okay, this will be equal to the current through the capacitor. Understand? So why I am saying you can replace the capacitor by short circuit, because initially your capacitor is not charged. Okay, so the moment you apply any voltage, okay, the moment you apply any voltage to RC circuit, capacitor cannot change its value of the voltage, okay, suddenly. That you have to understand. Okay, so what is the main important concept here is, capacitor does not change its voltage, okay, suddenly, you can say. And what is the reason behind that? Because capacitor takes time to charge. Okay, so the moment you apply some voltage here, the moment you apply some voltage here, right, capacitor cannot charge instantaneously, right, or suddenly. Okay, so it has to be replaced by short circuit. And only the situation when you can replace this capacitor by short circuit, this is also very important concept, right? Whenever there is a resistor, okay, whenever there is a resistor and the capacitor, remember this concept, okay, this is very important concept. Okay, whenever R and C are connected in series, you see here they are connected in series. I mean, if you forget about this output side, so this R and C are connected. Okay, R and C, right? Okay, so what you can do here is, then only if you are applying some voltage here, okay, so initially you have to replace this capacitor by short circuit. Okay, suppose we have situation of this kind, let me show you. Suppose we have one capacitor here, right, and there is no resistor, right? Suppose this is a capacitor and we are applying some t equal to 0, right? The step we are applying. Okay guys, can somebody tell me, can we replace this capacitor by short circuit? Anyone? Can we replace this capacitor by short circuit? Can we replace this capacitor by short circuit? What will happen if you are going to replace this capacitor by short circuit? Initially your capacitor is not charged. Okay, initially your capacitor is not charged, and if you are going to apply the step, guys, so can we replace this capacitor by short circuit? That is very important concept. Okay, no. Why? Because if you will replace it, so in front of the capacitor there is a 5 volt, or you can say some volt is there, right? So if you will apply the KVL, KVL will be violated in this case. Okay, because in the parallel, two different voltages cannot be connected in parallel, right? Okay, because if you replace this capacitor by short circuit, okay, so what will happen? You have to always keep this in mind. Okay, there will be a violation of KVL, right? So we can't replace this guy by short circuit. Okay, we can't replace this guy by short circuit. That you have to keep in mind. Chalo, let me come back here. So you see guys, how capacitor is charging. Your capacitor is charging when this current is flowing. You can say 5 by R current is flowing. Okay, so can we write like this? Let me go ahead. You can say that your capacitor is charging, right, and this is short circuit. Okay, so this IC will be equal to what? C dVc by dt, and which is equal to what? 5 voltage by R, because we have connected here the step t equal to 0. Okay, this is very important. What happens, many students, what they do is, they always replace the capacitor by short circuit, okay, without thinking. Okay, They think that initially voltage across the capacitor is 0, okay, and they do not see that, okay, if you are giving input and whether input is connected in parallel or not, okay. If input is connected directly to the capacitor, you can't replace the capacitor, you know, by short circuit, okay, initially. That you have to keep in mind, guys, okay, that you have to keep in mind. Fine. I hope this makes sense to all. Yes, guys. So this is very important concept, okay. This is very important concept that you have to keep in mind. When our capacitor will be of this nature, suppose I am showing you, see here, this is the capacitor and this is the capacitor, right? And I'm connecting one resistor here, right? You can say. Now we are giving step here at t equal to 0, 5 volt, okay. This input is changing at t equal to 0, guys, okay, from 0 to 5 volt. So now can you tell me, initially all the capacitors are not charged, okay, they are discharged, okay, they are at rest, they are very happy. Now you are giving input to the input to this circuit. So can somebody tell me, can we replace capacitor by short circuit in this case at t equal to 0? I mean, the moment you apply the circuit, the moment you apply the input, what will happen? Think about it. Because as everybody knows, capacitor does not allow change suddenly. Yes, capacitor cannot change its voltage across the voltage across the capacitor suddenly. Okay, we can't replace it by short circuit. Okay, then what you will do? You always used to do what, guys? You always used to replace it by short circuit, and then you got stuck in the problem, right? Okay. So this is what I wanted to explain, guys. Okay, when you can replace the capacitor by short circuit and when you can't replace the capacitor by short circuit. Okay, initially I'm saying initially. Hello. So we will understand this circuit as well. Don't worry. Right now, just I have shown you this. Yeah. So okay. So you see here, guys, as I have taken this is the R and this is the capacitor. Okay. Okay. So initially, the moment you apply the step here at t equal to 0, that is 5 volt. The current here is flowing, you can say, is 5 by R. Okay. The similar current will be flowing here as well, right? So you can say that C dV by dt is equal to what? 5 by R, right? So you can say that dV by dt equal to 5 by RC, 5 by RC. Okay, that you have to keep in mind. This is happening at 0 plus, you can say, at 0 plus. Okay, this is happening at 0 plus, or when you apply the input. So what is the meaning of this? Can somebody tell me what is the meaning of this? This is what is the meaning of this? This is the initial rate, guys. Initial rate at which capacitor is charging. Right? This is the initial rate at which the capacitor is charging. Okay, mathematically you can say that this is the slope, initial slope. What? It is the initial slope, right? So if I want to find the voltage across this capacitor VCT, right, so we can directly start plotting this. Okay, you see here, what is this initial slope, guys? This is the initial slope I'm talking about. This initial slope is nothing but 5 by RC, the 5 by RC, right? Rate of change of voltage, okay, at the moment you apply the input is what? 5 by RC. How I have found out this 5 by RC? Okay, yeah, initial rate of change. Yes. So whenever you will be given, like you will go for the interview, they will give you RC circuit, right? No matter any company you talk about, Texas, Intel, Qualcomm, IIT, any ISC you go, ISC, IIT, okay, they will give you RC circuit. They will give you step input and they will ask you that what will be the initial rate? Okay, so initial rate is what? 5 by RC. Okay, so your capacitor started charging, and what will happen as time progresses? You will reach to the steady state, right? As time progresses, you will reach to the steady state. Your capacitor will charge fully. Okay, okay. So what will be the steady state voltage? We call it steady state voltage, right? Steady state. At steady state, what will happen? At steady state, voltage across the capacitor will be constant, guys. Voltage across the capacitor will be constant. Okay, voltage across the capacitor will be constant. Why constant? Because it will fully charged. And what will be that voltage, guys? Suppose input is 5 volt. Okay, 5 volt input you are connecting. The steady state voltage across the capacitor will be what, guys? Tell me here. What will be steady state voltage, or you can say voltage at t equal to infinite? Okay, steady state means what? T equal to infinite you can consider, right? So the voltage across the capacitor will be what, guys? The ultimate, the final voltage I'm talking about. Okay, steady state voltage means final voltage across the capacitor. Okay, that is gonna be 5 volt only, right? Why 5 volt? Why 5 volt? Why 5 volt? See, as we know that at steady state, the voltage across the capacitor will be constant. You know, this is the input we have connected. You see, this is the input. Maximum voltage is what? This is maximum voltage 5 volt. Okay, and your capacitor will charge till 5 volt, right? So you can say that this is the initial rate, and it is charging like this. It is charging like this, and it has got steady state now, right? Okay, till 5 volt your capacitor will charge. The moment capacitor will charge till 5 volt, guys. Okay, so can somebody tell me what will be current flowing through the capacitor at steady state? Anybody? Divyani, can you tell me if the voltage across the capacitor at steady state is constant? So can you tell me what will be the current through the capacitor? Have you ever thought like this? Hmm? What will be the current through the capacitor? Initially current is flowing what? V by R, the 5 voltage upon resistance. That current is flowing. What will be the final current through the capacitor? Okay, if the voltage across the capacitor at steady state is constant, you know, again you can use the concept called IC. Okay, IC is gonna be what? C dVc by dt. Okay. So if this guy is constant at steady state, right? So this will be 0. Okay. The final current which will be flowing through the capacitor will be 0. What is the meaning of that? How can we realize that the current is 0? You have to replace the capacitance by open circuit. Okay, so at steady state, remember, at steady state, what will happen here is that at steady state, I'm saying, at steady state your circuit will look like this. You can say V final. Okay, this is the step we are applying at t equal to 0, that is 5 volt. This is R. So what is the voltage across the capacitor, guys? This is the capacitor, we have made it open. So this will be 5 volt. Okay, how many of you understood this? How many of you understood? The final voltage which will be across the capacitor is 5 volt. And why we are opening this capacitor? Because the steady state voltage will be constant and C dVc by dt will be 0, right? The current through the capacitor will be 0, right? At final. Why current is flowing through the capacitor, that you have to understand, because we want capacitor to charge. And what is that rate at which the capacitor is charging? That rate is basically dVc by dt. Okay, so initial rate and the final rate. ठीक है, आप यहाँ से wave form से भी देख सकते हो कि now the wave form is looking like this. What is the slope of this? Tell me here. What is the slope of this? This slope is 0, guys. You see, final slope is 0 and there is an initial slope. Yes, guys, are you able to see? Are you able to see final slope or not? Okay, that is the reason we are removing the capacitor by open circuit. Okay, how many of you understood this question? I mean, RC circuit. Okay, how RC circuit works. Hmm? Now we have to capture this waveform, whatever waveform we have got like this. How can we write in mathematics, right? That you have to understand. Okay. So what is the situation here, guys? See, there are various ways of getting that equation, but I will be giving you direct only. I will not solve the differential equation and all, right? Because writing differential equations and then solving that will not, I mean, it is easy. I will take that those things in later, okay, at later stage. Okay. So what we have to do, let me now solve properly, right? You see, this is the R, this is the capacitance, R and okay, they are asking that what is the voltage across this capacitor, and if we are applying the, you can say, you can say this is V input, right? V input at t equal to 0, right? If they will ask you what will be the output waveform, so you can directly draw it, guys, without having second thought in your mind. Consider that the capacitor is not charged. Capacitor is at rest. Okay. What is the when your capacitor is at rest? You can say Vc of 0 minus equal to 0. Okay, initial voltage is 0, right? Or you can say Vc of 0 plus is also 0. Okay. When it is true, okay, before switch it is 0, after switch is closed it is 0, right? So what you can do here is you can directly write, you can directly find the initial voltage. What is the initial voltage across the capacitor, guys? What is the initial voltage across the capacitor? Anybody? Huh? What is the initial voltage, guys? You can write this. Initial voltage across the capacitor, you can say 0 plus equal to 0. And what is final voltage across the capacitor? What is the final voltage across the capacitor? Needless to write 0 plus, just it is enough. It is V in, right? It is V in this case. Okay. You will be able to find these two things. You have to find initial voltage through the capacitor across the capacitor. You have to find final voltage across the capacitor. Okay, I have explained all the dynamics. Okay, how final voltage we are getting. Okay, because at steady state capacitor will be replaced by open circuit, so entire voltage will be across the capacitor. Initial voltage मैंने बता दिया कि capacitor will not be charged and capacitor cannot charge instantaneously, right? There will not be any initial charge if capacitor is already discharged, right? Okay, and when it will be 0, when there will be resistance and then followed by the capacitor. Okay, if there is no resistance followed by the capacitor, you can't say that your capacitor will be charged, I mean it will be replaced by short circuit. Okay, because there will be a violation of KVL that you have to protect. Okay, because any laws are there, guys, you don't have to violate it. Okay, देखो V आ गया, V final आ गया, then you have to find one of the very important parameter of the circuit, RC circuit I am saying, that is known as time constant. Okay, and time constant is the intrinsic property of the circuit, right? Remember this. Okay, okay, time constant is the property of the circuit, remember. Okay, time constant is what, guys? The property of the circuit is the property, internal property of the circuit. Okay, so what you have to do while finding the time constant, remember this, while finding the time constant, what you can do, you replace this voltage source, the input voltage, by what? By short circuit. Already you know how to replace ideal voltage source by short circuit, right? I mean, so you can replace that voltage by short circuit. Okay, understand, guys? So now what you have to do, you can replace this guy by short circuit. Okay? So this is the capacitance, right? Now this is R and this is, so whenever you're trying to find the time constant, you have to always see through capacitance. Okay, see through capacitance and find out R equivalent. What is that? See through capacitance. So if you're seeing from here, what is R equivalent, guys? R equivalent is basically R only. If you are looking back to the network from the capacitor, okay, this is just like a finding Thevenin equivalent, right? We always look back to the circuit to find R equivalent, okay? So whenever you're trying to find the time constant of the circuit after t equal to 0, right? Remember, we always calculate time constant of the circuit after the switch is closed, okay? Once the transient has happened, right? So now the question is what will be R here, and the capacitor is C here. So time constant of the circuit is going to be what? Tau, you can say, is going to be R times C. Simple. And this is the standard model. This is the standard RC circuit, right, guys? This is RC circuit, or you can say single time constant circuit. Okay, we sometimes call it single time constant circuit. Okay. So you should know one very important equation, right? Voltage equation for capacitor, okay? Or this voltage equation is applicable for any sort of element, whether you are trying to find voltage across a resistor or voltage across the capacitance or inductor, okay? Or you can say voltage across the not current across the inductor, right? Okay. So what you can say here is that voltage, final voltage will be equal to VCT equal to V final plus V initial minus V final times e raised to power minus t by tau. This is the equation that you have to remember, okay? That you have to remember, okay? See, this equation has got different interpretation as well that I will show you, okay? You can write this equation differently. What is this difference? This is the difference between initial and final voltage. Okay, initial and final voltage. Find initial and final voltage. So now you can write the direct equation. You know all the values. VCT equal to what? V initial, V final is, you can say V in plus V initial is 0 minus V in e raised to power t by RC. So VCT equal to what? V in common. Okay, 1 minus e raised to power t by RC. This is the equation, okay, for that waveform which we have got like this. Okay, this waveform we have got now. This waveform. What is this waveform? You can write that as 5 times 1 minus e raised to power t by RC. Okay. Okay. The moment you understand this circuit completely, you can directly write that waveform in terms of math. How many of you understood completely? I mean, the RC circuit. What kind of question they will be asking is, if there is a RC circuit, I'm talking about this particular circuit, guys. Okay, I'm going to bring capacitance. Okay, don't worry. Two capacitors I will connect. I will connect the step voltage, right? Then the situation will differ. Here, the initial rate of change is what, guys? Finite. Okay. Initial rate of change of initial rate is finite here. Okay. Initial rate is finite. Okay. The finite current is flowing. Okay. If the finite current is flowing through the capacitor, okay, then your capacitor will charge gradually, right? Okay. Okay. How can capacitor charge suddenly, right? How can you charge the capacitor suddenly? Okay. How can you charge? When infinite current is flowing through the capacitor. Infinite current is flowing through the capacitor. Okay. When can you charge the capacitor suddenly, guys? Directly you can charge the capacitor, okay? When it is possible, only when infinite current is flowing. अगर वहां पर finite current flow हो रहा है, if there is a finite current flowing through the capacitor, your capacitor cannot change its voltage instantaneously, or you can say suddenly. ठीक है, ये सिचुएशन सबको याद रहेगा क्या? आपको सोचना है. You know, when I was giving my interview once upon a time, one of the professor at IIT Madras, he asked me that, Dheeraj, can you tell me what will be the what will be the initial rate of this RC circuit? How? Okay. I said, sir, I was not able to understand, okay, because I know people at t equal to 0 plus, t equal to 0 minus, t equal to 0, this, that, okay. So guys, this is the step, okay. So what is the step here that you have to follow always? Okay. That is the very important case. Now let me bring one more circuit, okay, to understand. Suppose we have got one resistor here and one more resistor I'm connecting, and we are connecting capacitor in this case here. You see, suppose this is R, this is R. The same voltage you have to find here, VCT, and we are applying step only at t equal to 0. This is our favorite input, right? You can say 5 volt. So guys, can somebody tell me what will be the initial voltage across the capacitor? Anyone? What will be initial voltage across the capacitor? Devans, Divyani and everybody please answer. Answer me. VC 0 plus I am asking. VC infinity I am asking. And the time constant of the circuit tau I am asking. These three parameters are required. And by looking at the circuit only you can answer the question, right? You don't have to worry about anything, guys. What I'm considering is voltage across the capacitor initially is 0, right? Your capacitor is not charged. ठीक है, क्या होगा VC initial? Yes, if step is applied at t equal to 0, that is 5 volt. You see guys, this time what is happening here is we have connected these two resistance across the capacitor, right? So V initial will be 0 only, right? V initial will be 0 because capacitor does not allow sudden change, okay? Sudden change. And V final will be what? V final, you are applying 5 volt here, and the capacitor will be, you can say capacitor, you can just open it, right? At a steady state, capacitor can be replaced by open circuit, right? So what will be the voltage across the capacitor? It will be divided across this. Whatever voltage will be here, the same voltage here, because this time I'm not applying this step voltage directly to the capacitor. There is a divider R and this, okay. What is the voltage across this resistance? It is gonna be 5 into R by 2R, that is 2.5 volt. The final voltage across the capacitor will be, yes, yes, yeah, it is 0 certainly, but I'm talking about final voltage. The final voltage will be divided, okay, this time, okay. Okay, the final voltage across the capacitor will be 2.5. So what is the voltage then? What is VCT directly? V final is what? V final is basically 2.5 plus initial is 0, 2.5 e raised to power minus t by tau. Can somebody tell me what is the value of tau in this case? Tau is going to be what? What will be tau? What is going to be tau, guys? I'm talking about time constant of the circuit, like that is the property of the circuit, okay. So you don't have to worry about this voltage source. You just replace it by short circuit, okay. So if you replace this guy by short circuit, you can replace it by short circuit and T through the capacitance, okay, resistance from the, okay, this. Find out R equivalent from here. So these R and R parallel. So R equivalent will be R by 2, right? Time constant of the circuit will be RC by 2. So can somebody tell me if we are, yeah, RC by 2, perfect. If these two are, okay, we have connected the, in front of capacitor, we have connected this voltage divider, okay. So can this change your initial rate? Can this change your initial rate of the capacitor? Initial rate will be changed or same? What will be initial rate, guys? What is going to be the initial rate? Anyone? Initial rate of the, okay, that you have to understand, okay. This is very important concept, okay. So what will be the initial rate of charge of the capacitor, okay? That you have to understand always, okay. So you can also find initial rate from here also. You can differentiate this guy, just write this as 2.5, okay, 1 minus e raised to power t by r c by 2, right? So what do you think, guys? What will be initial rate, I am asking? Yes, initial rate of change, like we have calculated last time. See, for this circuit, R and C, suppose input is 5 volt at t equal to 0, step I am applying. So initial rate or initial slope or initial rate we got here is 5 by RC. I mean the input upon time constant of the circuit. Okay, so if I'm connecting the voltage divider in front of the capacitor, right? The same circuit, same input, okay, R and C. So can somebody calculate what is the initial rate now? Initial rate at which the capacitor will charge. Will it be same or different? Anyone? Will it be same or different? Yes. This question was asked by me, by one of the professors. His name is Professor Santi, right? He asked me this kind of question and I was not able to answer any question. Since then I decided that I'm gonna teach this subject, okay? Okay, so how can one become a teacher, right? If he fails, he doesn't know anything, he will start exploring, right? Then he will become a teacher, yeah. So you see this, guys. Devans, can you calculate quickly what will be the initial rate at which the capacitor will start charging? वो जो initial rate आता है, हाँ, क्या होगा initial? Same होगा, different होगा दोनों circuit का? Tell me fast. Initial rate will be same, guys. The initial rate is gonna be 5 by RC only. Okay, that you can see here. Initial rate will be same. ठीक है? Okay. Initial rate will be same. ठीक है? This is very important to understand. Why initial rate will be same? I'm just going to show you. You can Thevenize from here. Okay, you can Thevenize from here. So the Thevenin voltage will be, okay, that is 2.5, and this is the RC circuit only, guys. So this is the RC circuit. This is R by 2, nothing else, right? You can Thevenize from here. Thevenize. Okay, can you Thevenize? If you find, yeah. See, the moment, suppose this kind of a situation is given for you to calculate. Okay. So you know the well-known RC circuit, right? So this is the situation where step is applied at t equal to 0. That is 5 volt. This is R, this is R, and this is C. See, I can also do what? I can also connect the 5 volt and apply the switch. Okay, and we can say that switch is closed at t equal to 0. So same. Okay, if switch is connected, or you can say if step is applied, both are same. Okay, so in this case what you can do, you can Thevenize from here. Okay, Thevenin was a guy who sees the circuit back to the network, okay, back to circuit, he always see one resistance and one voltage. Okay, so you can say this is one voltage here, and I mean this is the voltage which is step voltage at t equal to 0. What will be the voltage across this? Thevenin voltage, 5 volt is there na, so it is 2.5, and this is the R, that is R by 2. Okay, and this, so again you got the RC circuit only, and I think analyzing RC circuit is very simple job. Yes, analyzing RC circuit is very simple job. Are you able to see, guys? It depends upon how you are looking through the circuit, right? How you are looking at the circuit, that matters a lot. Okay, everybody understood or not? So how soon you can simplify the circuit, that matters. Okay, ठीक है. So this is one of the important concept. Next concept is what? Suppose, so in this case the initial rate is gonna be same, right? Okay, initial rate will be same only. Initial rate is not going to change. Now let us take one more case, important case. What is that important case that you have to understand? Suppose we are connecting this R, this capacitance C, and there is one more capacitance we can connect here. Okay, and we are applying the voltage at t equal to 0, that is you can say 5 volt. Okay, or V in, you can say this is R. Now we have to find the voltage across this capacitor VCT. Yes. So guys, can you tell me what will be the initial rate? What will be the initial rate? Okay, देखो, these two capacitances are connected, right? And we are considering that the capacitor, this is important guys, in nowhere you will find this concept, okay? Nobody explains. Okay, so you have to understand this. Initially capacitor is at rest, right? Okay, capacitor is at rest and capacitors are, you see. Now the moment you apply the voltage at t equal to 0, okay, so what will happen with the capacitor? Anybody, what will happen with the capacitor? बताइए जल्दी से. What will happen with the capacitor? Whenever I see this kind of a circuit, I become really elated and happy. Yes. What will happen with the capacitor? Anybody? See, the moment you apply the circuit, the moment you apply the step input, okay, so see, you are giving input as a step, so you are finding the output as step response. Basically we call it step response. Okay, so you are applying input as a step, right? So certainly you will think that these two capacitors are not charged, so initially capacitor does not allow current to flow. Yes, everybody is thinking like this. Okay, and how many of you thinking like this? Tell me. Yes guys, this is the important concept which I want to tell you. Initially capacitor is not charged, right? Initially capacitor is not charged, and this is the situation. Okay, this is the situation. So these two capacitors are sorted. If you think that these two capacitors are sorted, right, so let me draw the situation according to you. The mistake what we will do here is, initially you can say at t equal to 0 plus, capacitor will sort, and this is sort. I mean, you can also replace this guy by sort. ये सब लोग करेंगे ऐसा. जैसे ही आप t इक्वल टू 0 में 5 वोल्ट अप्लाई करोगे, सब लोग कर देंगे ऐसा, है ना? ठीक है, ये दिस इज द कॉमन मिस्टेक पीपल डू. ठीक है, so what will happen guys, you are applying 5 volt across this, and the voltage here is what? Voltage here is 0. So violation of KVL will happen. Okay, violation of KVL will happen. That you have to always keep in mind. Violation of KVL will happen. Okay, ठीक है. So I don't want KVL to violate. Okay, so what we will do? We will allow capacitor to change suddenly. ठीक है. Okay, we will allow capacitance to change suddenly. Okay, its initial voltage. ठीक है. That is very important concept that you have to understand. Don't sort the circuit, don't sort the capacitor. Okay, okay, remember this is very important. Don't short circuit the capacitor when source voltage and two capacitors are in loop. Okay, are in loop. Okay, you see here, there are two capacitors, they are in loop. Okay, so never do like this. Okay, understand? Then what you have to do, whenever this situation happens, right? ठीक है, so we see you have to find VCT across this. You can say this is C1, this is C, right? The R, and we are applying step here at t equal to 0. Okay, so t equal to 0. So you know that initially finite current will be flowing through the resistance. Okay, initially finite current will flow through the resistance. You can say 5 by R, right? But these two capacitors, you know, we will say that these capacitor will suddenly charged as well, right? So if capacitor charges suddenly, okay, if capacitor charges suddenly, what is the meaning of that? Capacitor has to charge suddenly. Okay, why capacitor has to charge suddenly? You know, you have to compulsorily, you know, if voltage source and capacitors are connected in loop, keep in mind this. Okay, this resistance is not playing any role. Okay, you see, if voltage and capacitance are connected in loop, so capacitor has to change suddenly. Okay, capacitor has to change its voltage suddenly, guys. This is very important concept I'm telling you, right? So what will happen here is that capacitor has to change charge suddenly or change its voltage suddenly. How it is possible? When infinite current is flowing. Current is flowing. Okay, has to charge suddenly, or you can say has to change its voltage suddenly, right? Initial voltage suddenly, because initial voltage across these two capacitors are 0, right? So you can say that both capacitor has to change its initial voltage suddenly. Okay, why so? ऐसा क्यों करते हैं? अब देखो, जब वोल्टेज, जब कैपेसिटर विल, you know, when capacitor will change its voltage suddenly, then what will happen? Infinite current will flow, right? तो आपको पता है, if there is a infinite current, you can say infinite current is flowing in this through this capacitor, infinite current is flowing through this capacitor, you know, what is flowing? No, finite current is flowing. मान लो ऐसा करते हैं कि ये कैपेसिटर चेंज नहीं करता है, it does not allow, you know, it does not allow sudden change, but this capacitor has to charge suddenly. So here infinite current flow होगा, यहाँ पर finite और यहाँ finite, तो क्या हो जाएगा guys? At this node violation of what? Violation of KCL will happen. Violation of KCL, ठीक है? अगर आप ऐसा सोचते हो कि चलो ठीक है, वी आर अप्लाइंग स्टेप हियर, ठीक है, ये वाला कैपेसिटर जो सी है ये अपने आप को चेंज करेगा, ठीक है, वो बोलेगा भाई ठीक है, नाउ आई एम गोइंग टू चेंज माई सेल्फ, आई मीन आई एम गोइंग टू चेंज माई इनिशियल वोल्टेज, तो C1 बोलेगा नो आई एम नॉट गोना चेंज, ठीक है. When this situation will happen, so what will happen? See, C1 से finite current, I mean finite current flow होगा, C जो ये C है उससे infinite current flow होगा, क्योंकि C is saying that okay initial voltage will change suddenly, और R से भी finite flow हो रहा है, तो finite equal to infinite. Is it possible guys? Tell me, is it possible? It is not possible guys, because KCL will get violated, ठीक है. तो KCL वायलेट ना हो तो हम क्या बोलते हैं कि दोनों कैपेसिटर को चेंज होना पड़ेगा, दोनों कैपेसिटर को चेंज होना पड़ेगा, ठीक है. जब दोनों कैपेसिटर विल चेंज इट्स इनिशियल वोल्टेज सडनली, तब लाइफ थोड़ा सिंपल हो जाएगी, तब KCL वायलेट नहीं होने वाला है, तब वहां KCL एप्लीकेबल होगा, लेकिन KCL विल नॉट बी एप्लीकेबल इन टर्म्स ऑफ करंट गाइस. करंट इनफाइनाइट है, करंट इनफाइनाइट से क्या, सो KCL इनफाइनाइट जब करंट फ्लो होगा तो वहां तो आप डायरेक्टली आप बोल सकते हो कि वोल्टेज अक्रॉस द कैपेसिटर इज द यू नो व्हाट एवर इनपुट यू आर अप्लाइंग, राइट. वो तो स्टडी स्टेट का केस हो जाएगा. तो हम क्या करेंगे यहाँ पर, दिस इज वेरी इंपॉर्टेंट नोट दैट यू हैव टू पुट हियर, ठीक है, यहाँ पर याद रखना I'm just giving you this important line. Okay, suppose you want to find VC 0 प्लस, मतलब इनिशियल वोल्टेज आपको फाइंड करना है अक्रॉस द कैपेसिटर, ठीक है, क्योंकि आपको पता चल चुका है कि बोथ कैपेसिटर हैज टू चेंज इट्स इनिशियल वोल्टेज, क्योंकि इनिशियली बोथ कैपेसिटर वाज नॉट चार्ज, ठीक है, दोनों कैपेसिटर के अक्रॉस वोल्टेज 0 था, अब दोनों को हमें चार्ज करना है, ठीक है। तो आपको क्या करना पड़ेगा, ये लाइन याद रखना, बहुत इंपॉर्टेंट लाइन है। अगर आपको VC 0 प्लस फाइंड करना है, इट कैन बी एनीथिंग, ओके, वोल्टेज अक्रॉस द कैपेसिटर और एनीथिंग यू कैन से, राइट। सो आप क्या कर सकते हो, नंबर 1, दो सिचुएशन आपके साथ आएंगी, ठीक है, देयर विल बी टू सिचुएशंस, ओके। वन सिचुएशन विल बी व्हाट, इफ देयर इज नो voltage source, if there is no voltage source, or you can say capacitor, okay, in loops, okay, then what you have to do for finding VC 0 plus, मैंने बताया था, क्या किया था आप लोगों ने, रिप्लेस द कैपेसिटर बाय शॉर्ट सर्किट, क्या किया था, शॉर्ट सर्किट द कैपेसिटर, okay, short circuit the capacitor and find the initial voltage, okay, this is one situation, okay. So in this case these two capacitors and there is a voltage source which is coming out to be in loop, okay, तो इस केस में आप शॉर्ट सर्किट नहीं कर सकते हैं इनिशियल वोल्टेज फाइंड करने के लिए। सबको समझ आया क्या, ये प्रॉब्लम बहुत बड़ी प्रॉब्लम है, ठीक है। तो आप क्या करोगे, व्हाट यू हैव टू डू, सेकंड पॉइंट इज, इफ देयर आर वोल्टेज सोर्सेस, इफ देयर आर voltage source, okay, slash capacitors, okay, in loops, okay, in loops, तो आपको क्या करना पड़ेगा, then you then apply KCL in terms of charges, okay, and KVL, right, and KVL, and then find out the voltages, okay, क्योंकि वहां पर दो वोल्टेज होगा, दो इनिशियल वोल्टेज अक्रॉस द कैपेसिटर, देयर आर टू कैपेसिटर्स ना, यू हैव टू फाइंड VC1 0 प्लस एंड VC 0 प्लस, ठीक है। और इस रेजिस्टेंस का हमें क्या करना है, ये रेजिस्टेंस आप क्या कर सकते हो गाइस, यू कैन नेग्लेक्ट इट, ओके। तो व्हेन एंड रजिस्टर, while finding the initial voltage you can neglect this resistor in parallel with capacitor can be neglected, अब देखो मैं कैसे करता हूं, नाउ द क्वेश्चन इज हाउ टू राइट KCL इन टर्म्स ऑफ चार्जेस, ये भी इंपॉर्टेंट है, क्योंकि करंट इनफाइनाइट फ्लो हो रही है, ठीक है, करंट जब इनफाइनाइट फ्लो हो रही है तो वी नीड टू ब्रिंग इन द कॉन्सेप्ट ऑफ चार्ज, राइट, ओके, understand? So what we can do here is just keep the capacitor as it is, okay, there is a voltage source, you can say VS, and we have applied VS like this, t equal to 0, you can say यहाँ 5 वोल्ट है, ठीक है, ये C1 है, ये C है, तो वोल्टेज अक्रॉस दिस इज व्हाट, VC1 0 plus we wanna find, and voltage across this is 0 plus, okay, VC 0 plus and VC okay. So guys, you have to understand that at this node from this capacitor charge suppose Q1 is flowing, यहां से कितना चार्ज फ्लो हो रहा है, Q फ्लो हो रहा है, ठीक है। आपको याद रखना है कि ये दोनों चार्ज दोनों कैपेसिटर से क्या होंगे, सेम होंगे, क्योंकि दोनों कैपेसिटर सीरीज में हैं, तो आपको पता होना चाहिए टोटल चार्ज क्या होगा, Q1 इक्वल टू Q, राइट। और वोल्टेज चार्ज अक्रॉस दी फर्स्ट कैपेसिटर कितना है, आपको पता है Q इक्वल टू CV होता है, Q इक्वल टू CV, राइट। ठीक है, ये आपको याद होना चाहिए। तो Q इक्वल टू CV का मतलब क्या हो जाएगा, इसके अक्रॉस कितना चार्ज होगा, यू कैन से Q1 इज गोना बी C1 टाइम्स V1 0 प्लस, एंड Q इज इक्वल टू C टाइम्स VC 0 प्लस, ये VC1 है। तो KCL से आप बोल सकते हो कि दोनों चार्ज इक्वल होंगे, तो आप बोल सकते हो कि C1 VC1 0 प्लस इज गोइंग टू बी VC 0 प्लस। ठीक है, एक ये इक्वेशन आ जाएगा, फर्स्ट इक्वेशन। सेकंड इक्वेशन आपका क्या आएगा, व्हाट इज द वोल्टेज इफ यू अप्लाई दी KVL इन दिस लूप। ठीक है, अगर आप पहली गलती नहीं करते हो कि कैपेसिटर को शॉर्ट सर्किट से रिप्लेस कर दिया तो KCL वायलेट हो जाएगा। तो KCL अगर आपको यहां लिखना है तो इन टर्म्स ऑफ व्हाट करोगे, यू कैन अप्लाई द KVL हियर। सो पहला क्या है, माइनस VS, द सोर्स वोल्टेज माइनस VS प्लस VC1 0 प्लस VC 0 प्लस इक्वल टू 0। तो यहां से VS कितना आ गया, VC1 0 प्लस VC 0 प्लस इक्वल टू, ओके नॉट इक्वल टू 0, जस्ट यू कीप इट लाइक। तो ये सेकंड इक्वेशन आ गया। जब आप इक्वेशन 1 एंड इक्वेशन 2 को सॉल्व करोगे गाइस तो आपको रिजल्ट आएगा। ठीक है, ये चीज आपको एग्जाम में नहीं करना है, जस्ट यू हैव टू डू हियर ओनली, राइट। सो व्हाट इज द इनिशियल वोल्टेज अक्रॉस दिस C1 कैपेसिटर, आपको याद रखना है जब आप सॉल्व करोगे। सॉल्विंग इक्वेशन 1 एंड 2, आपका VC1 आएगा, VC1 0 प्लस विल बी इक्वल टू VS टाइम्स C अपॉन C1 प्लस C, एंड VC2 0 प्लस विल बी इक्वल टू व्हाट, टोटल वोल्टेज VS टाइम्स C1 अपॉन C1 प्लस C2। I mean, you can say that this is VC, simple. Do you know how to apply voltage division when two capacitors are connected in series? हाँ, आपको जैसे करंट में आप वोल्टेज डिवीजन लगाते हो ना, करंट डिवीजन सॉरी, वहां पर करंट जब दो रेजिस्टेंस पैरेलल में होते हैं, सेम टाइप से आप यहाँ पर वोल्टेज डिवीजन लगा सकते हो। ठीक है, तो ये जो हम एक्सप्रेशन हमें मिल रहा है, दिस एक्सप्रेशन वी कैन डायरेक्टली राइट इन टर्म्स ऑफ व्हाट गाइस, इन टर्म्स ऑफ like directly applying the voltage division, you know, suppose this is these two capacitors are there, right, और यहाँ पर मान लो कोई वोल्टेज सोर्स यहाँ लगा हुआ है VS। अगर कोई पूछता है भाई ये C1 है ये C2 है, तो व्हाट इज द वोल्टेज अक्रॉस VC1, क्या बताएंगे यहाँ पर, टोटल वोल्टेज VS, एंड ये वाला कैपेसिटेंस C2 अपॉन C1 प्लस C2। ठीक है, यहाँ VC2 कितना आ जाएगा भाई, वोल्टेज डिवीजन से VS टाइम्स C1 बाई C1 प्लस C2। ये जो इक्वेशंस हमें आ रही है ना, these equation we are getting after solving those 1 and 2 equations। ठीक है, how many of you understood? ठीक है, तो आप डायरेक्टली फाइंड कर सकते हो इनिशियल वोल्टेज अक्रॉस द कैपेसिटर। ठीक है, आई होप दिस मेक्स सेंस टू ऑल। हाउ मेनी ऑफ यू अंडरस्टूड हाउ वी विल फाइंड द इनिशियल वोल्टेज अक्रॉस द कैपेसिटर। एक बार मैं फिर से लिख देता हूं यहाँ पर, देखो मान लो ये सिचुएशन है, जब भी ये सिचुएशन होगी आपको यही करना है। ये मान लो C1 है और दिस इज द कैपेसिटेंस हियर। ठीक है, आई मीन जस्ट अप्लाई द कैपेसिटेंस, क्योंकि t equal to 0, this is, you can say this is VS, right, VS. So this is C2, you can say, right. So what is the voltage across C2 guys, initial voltage 0 plus, इसको आप बोल सकते हो सर VS टाइम्स C1 अपॉन C1 प्लस C2, and VC1, this is VC2, right, and this is VC1 0 plus कितना होगा, because you have to find voltage across the capacitance, okay, both capacitance, because both capacitance are changing suddenly। ठीक है, आप स्टेप यहाँ दे रहे हो, यहाँ पर आप स्टेप दे रहे हो ना, तो ये वाला वोल्टेज भी स्टेप वाइज चेंज हो रहा है। कितना चेंज हो रहा है आप यहाँ लिख सकते हो, दैट इज VC2 0 प्लस, आई मीन VC1 0 प्लस, ये भी चेंज हो रहा है लाइक दिस। ठीक है, तो ये तीनों वोल्टेज मतलब इसके वजह से ये वोल्टेज चेंज होगा सडनली, ये भी सडनली। तो यहाँ पर कितना हो जाएगा, VS टाइम्स C2 बाई C1 प्लस C2। ठीक है, सो अगर आपको कुछ चार्ज का कॉन्सेप्ट नहीं भी आता तो आपको ये वोल्टेज डिवीजन तो आ जाएगा। ठीक है, सबको समझ आया क्या? ठीक है, तो इनिशियल रेट गाइस, रिमेंबर इनिशियल रेट, in this case initial rate will not be finite. Okay, initial rate will be infinite. Okay, आपका सिचुएशन कुछ ऐसा आएगा, अगर आप ग्राफ ड्रॉ करोगे तो ये ऐसा नहीं उठेगा, याद रखना। ये कैसा चलेगा, यहाँ पर इंपल्सिव करंट फ्लो होगी ऐसे, ये इनिशियल रेट है, फिर ऐसे चार्ज होना चालू होगा। What is the final voltage guys, tell me? These are the initial value we have got. What is the final voltage? Final voltage across the capacitor. ठीक है, तो हमारे पास रेजिस्टेंस है, ये कैपेसिटेंस मान लो ये C1 है, दिस इज कैपेसिटेंस C2, राइट, एंड वी आर अप्लाइंग दी T equal to 0 and this is Vs. Can somebody tell me what is V final or V infinity? You can say Vc to infinity कितना होगा? या ठीक है, यस यस। अब बताओ फाइनल वोल्टेज क्या होगा? सबको पता है फाइनल वोल्टेज क्या होगा। फाइनल वोल्टेज क्या होगा गाइस अक्रॉस द कैपेसिटर, सबको पता है, यू नो फाइनली योर कैपेसिटर विल चार्ज फुल्ली, राइट। जब वो फुल्ली चार्ज होगा, ठीक है, अभी तो ये इनिशियल वोल्टेज मैंने निकाला है, इनिशियल वोल्टेज से ऐसे से चार्ज होगा, ठीक है। चार्ज फुल्ली कब होगा? टिल Vs, मैक्सिमम वोल्टेज इनपुट वोल्टेज, राइट। तो आपको पता है कैपेसिटर ओपन हो जाएगा, जब कैपेसिटर ओपन हो जाएगा तो वी फाइनल के लिए सर्किट क्या बनेगा भाई, ये बनेगा। यहाँ पर आपका इनपुट था एट टी इक्वल टू 0 Vs, तो यहाँ पर Vc2 कितना आ गया, Vs आ गया, ठीक है। सबको समझ आया? नाउ यू कैन फाइंड द टाइम कॉस्ट ऑफ द सर्किट, इट इज वेरी सिंपल, राइट। क्योंकि दो कैपेसिटर आपके किस में है, पैरेलल में है, तो C1 प्लस C2 टाइम्स R, ठीक है। तो बहुत ही सिंपल कॉन्सेप्ट है ये, देखो यहाँ पर। अब हम टाइम कांस्टेंट निकालना चाहते हैं, यहाँ पर कैप्चर लगा हुआ है, ठीक है, ये C1 है, ये C2 है, इसको हम सॉर्ट कर देते हैं। तो यहाँ से हम देखेंगे तो R तो एक ही दिख रहा है, तो R इक्विवेलेंट तो R ही है, और आपका ये दो कैपेसिटर कंबाइन हो गया, तो C इक्विवेलेंट भी यहाँ से आ जाएगा C1 प्लस C2। तो टाउ कितना आ रहा है, R टाइम्स C1 प्लस C2, सिंपल। तो आप सीधा सीधा इक्वेशन लिख दीजिए, ठीक है। मान लो तुम्हारे पास सर्किट ऐसा है, अब देखो मैं डायरेक्ट निकालता हूँ, जब भी ऐसा सिचुएशन आएगा कभी, क्या दो कैपेसिटर हैं, वो लूप में हैं, किसके साथ, वोल्टेज सोर्स के साथ, ठीक है, लूप में, एंड इनपुट में क्या कनेक्टेड है, स्टेप कनेक्टेड है, राइट। तो आप इसका डायरेक्ट इक्वेशन लिख सकते हैं, इसके अक्रॉस Vct क्या होगा, यू कैन डायरेक्टली राइट Vct इज गोइंग टू बी, द V फाइनल इज Vs plus initial voltage across this Vc2 will be what? Initial voltage across this will be Vs times C1 by C1 plus C2, okay, minus Vs e raised to power t upon what is the time constant of the circuit, that is R times C1 plus C2. See guys, without solving this question I am able to write this expression. How many of you understood this? कितने लोगों को समझ में आ गया ये चीज, समझ आया क्या? आपसे अगर कोई पूछता है व्हाट इज द वोल्टेज अक्रॉस Vc1, ठीक है, ये तो Vc, ये इसके अक्रॉस Vc2, यू कैन से दिस इज Vc2 वी गॉट, राइट। नाउ इफ समबडी विल आस्क व्हाट इज द वोल्टेज अक्रॉस दिस गाय, इसके अक्रॉस कितना होगा, Vc1t, तो आप यहाँ भी लिख सकते हो, तो फाइनल वोल्टेज आपको पता ही है कितना होगा, ठीक है। फाइनल वोल्टेज इसके अक्रॉस कितना होगा भाई, सेम ही होगा, है ना। यू कैन से दैट Vs, राइट, प्लस इनिशियल वोल्टेज Vs C2 बाई C1 प्लस C2, ये इनिशियल वोल्टेज है, ठीक है। क्यों इनिशियल वोल्टेज है, आपको पता है कि दो कैपेसिटर वोल्टेज सोर्स लूप में कनेक्टेड हैं, अगर वो लूप में कनेक्टेड हैं तो उनको चार्ज होना जरूरी है, अगर इफ दे विल नॉट चार्ज देन लाइफ इज वेरी टफ, ओके, आग लग जाएगी, ठीक है। समझ में आया क्या? तो आई होप दिस मेक सेंस गाइस। कितने लोगों को समझ आ गया ये कॉन्सेप्ट? तो जब भी ऐसा सिचुएशन होगा, जब भी ऐसा सिचुएशन होगा गाइस, ठीक है, टाइम कांस्टेंट ऑफ द सर्किट तो सबका सेम ही होता है। ओके, दिस कॉन्सेप्ट इज क्लियर फॉर ऑल, और इज देयर एनी डाउट टिल नाउ? ठीक है, तो अब आपको आई थिंक सारे कॉन्सेप्ट बन जाएंगे आरसी सर्किट बेस्ड में, राइट? जब भी ऐसी सिचुएशन आती है गाइस, यू हैव टू बी केयरफुल, है ना? ओके, दैट इज माय मेन सजेशन, बी केयरफुल when voltage source and when voltage source and the capacitors are in loop, okay, and resistances are connected in parallel, okay, जब रेजिस्टेंस कनेक्ट होगा पैरेलल में, ठीक है, तो जब आप इनिशियल वोल्टेज निकालते हो तो उस रेजिस्टेंस का कोई मतलब नहीं है। मैंने सारे कंक्लूजन दे दिए हैं, एक बार आप इस सेशन को देखो दोबारा, और भी कॉन्सेप्ट रहेंगे, आरएल सर्किट के बारे में मुझे बात करना, और भी मैं इसमें डिटेल में बात करूंगा, ओके, क्योंकि ये सेशन ज्यादा लंबा नहीं होना चाहिए, 1 आवर का ऑलरेडी हो चुका है। तो प्लीज गाइस नाउ रियलाइज, लुक ऑल गेट प्रॉब्लम्स, जितनी भी गेट प्रॉब्लम आई हैं आरसी सर्किट बेस्ड में, केवल जहां आर और सी लगा हुआ है उसमें सब में देखो कि कौन सा क्वेश्चन कैसा है, कहां पर दो कैपेसिटर उसमें लगे हैं, ठीक है, कहां पर क्या है। 2012 में एक क्वेश्चन आया था गाइस, क्या क्वेश्चन था? ये कैपेसिटर है, यहाँ स्विच लगा दिया, ये कैपेसिटर है, एट टी इक्वल टू 0, ये वाला कैपेसिटर कुछ चार्ज था 5 वोल्ट, राइट? अब वो बोल रहा था कि भाई ये कैपेसिटर क्या होगा, Vc2 कितना होगा, ठीक है, Vc2 कितना होगा, ठीक है। अब क्वेश्चन ऐसा आया था, अब ऑप्शन में दिया था कि क्या करंट फ्लो होगी कि Vc2 में कुछ चार्ज आएगा। सबको पता है कि भाई जब दो कैपेसिटर काइंड ऑफ कनेक्टेड है, राइट, तो आपको इनफाइनाइट करंट तो फ्लो करवाना ही पड़ेगा, तभी ये वाला कैपेसिटर चार्ज होगा। समझ आया क्या? कैन यू रिप्लेस दिस सेकंड कैपेसिटर बाय शॉर्ट सर्किट, एनीबॉडी? हाँ, बताओ। तो यहाँ इनफाइनाइट करंट फ्लो होना जरूरी है। सी, अगर मान लो कोई कैपेसिटर है, रिमेंबर इफ एनी कैपेसिटर इज देयर, राइट, हैविंग इनिशियल वोल्टेज, ठीक है, तो आप इस कैपेसिटर को कैसे रिप्लेस कर सकते हो? आप बोल सकते हो ये एक वोल्टेज सोर्स की तरह काम करता है, राइट, Vc0 प्लस यू कैन से, ठीक है। अगर कोई कैपेसिटर है, इफ इट इज रिप्लेस बाय, आई मीन इट इज हैविंग इनिशियल चार्ज इन इट, तो आप उसको रिप्लेस कर सकते हो बैटरी की तरह, ठीक है, और वोल्टेज सोर्स की तरह। तो इस तरह क्वेश्चन आते हैं गाइस, आपको कॉन्सेप्ट नहीं क्लियर है, आप सोचते रहोगे, आप इंटीग्रेशन लगाओगे, डिफरेंशिएशन लगाओगे, ये करोगे वो करोगे, राइट। ये सोचो स्टडी स्टेट में कैपेसिटर क्यों ओपन होता है, ये समझना जरूरी है। देखो सिचुएशन समझो, अगर मान लो दो सर्किट मैंने लिए, एक सर्किट तो ये हो गया, ठीक है, ओके, दिस इज व्हाट आर सी, एंड यहां पर लगाया टी इक्वल टू 0 में 5 वोल्ट। है, मैं पूछ रहा हूं भाई वोल्टेज अक्रॉस दिस कितना होगा, और एक सर्किट मैं लेता हूं दिस, ओके, 5 वोल्ट, तो VCT, टेल मी गाइस, टाइम कांस्टेंट ऑफ दिस सर्किट, टाइम कांस्टेंट ऑफ दिस सर्किट, बताइए क्या होगा? दोनों का टाइम कांस्टेंट क्या होगा? व्हाट विल बी टाइम कांस्टेंट ऑफ द सर्किट? दोनों का टाइम कांस्टेंट क्या होगा गाइस? लाइफ में क्या दिक्कत है दोनों सर्किट में? पहला सर्किट तो दो कैपेसिटर एक वोल्टेज सोर्स दोनों लूप में है, ठीक है, उसमें तो बढ़िया है भाई, यू कैन शॉर्ट सर, कैसे इनिशियल वोल्टेज निकालोगे पहले वाले, सेकंड वाले में कैसे निकालोगे पहले वाले में, दोनों का केस क्लियर, और इनिशियल रेट दोनों का अलग अलग रहेगा। इसका देखो फाइनल वोल्टेज तो वही रहेगा, दोनों का फाइनल वोल्टेज क्या होगा, सेम रहेगा। फाइनल वोल्टेज इसका भी सेम रहेगा, फाइनल वोल्टेज इसका भी सेम रहेगा, ठीक है, ओके। लेकिन ये ऐसे चार्ज होगा, स्टार्ट से चार्ज होगा, और ये वाला कैसे चार्ज होगा, ये यहां से चार्ज होगा। डिफरेंस पता चला कि नहीं पता चला गाइस? ये बाई इंस्पेक्शन टेक्निक इसको बोलते हैं, कि आपको क्वेश्चन दिया हुआ है, विदाउट थिंकिंग यू कैन ड्रॉ द सर्किट, आई मीन विदाउट थिंकिंग यू कैन ड्रॉ द ग्राफ, ठीक है। बहुत सारे लोग हैं उनको समझ में नहीं आता कैसे ग्राफ को ड्रॉ किया जाता है, अंडर डैम्ड पता नहीं क्या क्या बातें करने लगते हैं, ठीक है। सिंपल आरसी सर्किट की बात कर रहे हैं, दोनों का क्या है भाई, टाइम कांस्टेंट, यस, 2 RC 2 RC। देखो कितना अच्छा सर्किट है ये। एक सर्किट ऐसा है जो दो कैपेसिटर और इंडक्ट इनपुट वोल्टेज सोर्स जो है लूप में है, एक में भी ऐसा सिचुएशन है लेकिन बीच में रेजिस्टेंस है, ठीक है। दोनों का टाइम कांस्टेंट सेम है, बट वेव फॉर्म्स अलग अलग हैं, फाइनल वैल्यू भी सेम है 5 वोल्ट, बट व्हाट इज द डिफरेंस हियर, इनिशियल रेट गाइस। आपका जो कैपेसिटर है सेकंड केस में फाइनाइट रेट से चार्ज हो रहा है, दैट इज 5/2 RC यू कैन, ठीक है, ओके। लेकिन इस वाले में कितने से चार्ज हो रहा है, इस वाले में इनफाइनाइट रेट से चार्ज हो रहा है, मतलब तुरंत चार्ज हो गया कैपेसिटर। सबको समझ आया क्या? तो दिस इज व्हाट आई वांटेड टू डिस्कस गाइस। अभी और पार्ट 2 मैं कंडक्ट करूंगा ट्रांजिएंट में, अभी ये बेसिक कॉन्सेप्ट मैंने बता दिया है, ठीक है। और भी डिटेल में हम चर्चा करेंगे, डिस्कस करेंगे। जस्ट आई हैव गिवन यू कॉन्सेप्ट सो दैट आपका माइंडसेट ओपन हो जाए कि कैसे सीखना है लाइफ में। सबको समझ आया क्या? तो अब याद रखना कि नेक्स्ट सेशन जो होने वाला है वो और तगड़ा होगा, जितने भी गेट की प्रॉब्लम्स हैं सारी प्रॉब्लम्स अपन डिस्कस करेंगे, और मैं आपको अपना असाइनमेंट शेयर करूंगा, आप उसको सॉल्व करना चालू करो, ठीक है। ओके गाइस, सो टेक केयर, बाय बाय एंड सी यू अगेन। तो आप लोग पढ़ने का तरीका चेंज कर दो, राइट, दिस इज द राइट वे ऑफ सॉल्विंग क्वेश्चन, और आपका कोई भी इंटरव्यू निकल जाएगा, कुछ भी हो सकता है, ठीक है। थैंक यू।